Hello students, I am Dr. Sanjeev Ponia. In last lecture, we discussed about the examination scheme as well as syllabus of computer graphics. In today's lecture, we will discuss about the overview of the computer graphics. When we are saying computer graphics means computer graphics is not limited to anywhere, means not limited to text, sound, graphs, object, or anything else. Means whatever we can perform using the computer, that is computer graphics. If we want to define computer graphics in simple words, then computer graphics is the creation of pictures, that is image or objects, and to perform some operation like transformations. There are lot of operations we will discuss later on, but at this point we are only considering any type of operation. So to perform any operation and present them on the display device, any display device. So computer graphics is the creation of pictures to perform some operations and present them using the computers or using any technology. The term computer graphics comes in existence in 1960 by William Fetter. He is a graphic designer and he designed a 3D structure of the human body at that time. So the term computer graphics came in 1960s by William Fetters in existence. When we want to discuss in computer graphics, then basically in broad sense, we can divide in two parts, or we can classify computer graphics on two parts. First one is non-interactive computer graphics and second one is interactive computer graphics. Non-interactive computer graphics is also called passive computer graphics. This is a one-way communication, means user do not have any control on the image, means user cannot edit or change the image or object. For an example, whatever we are seeing on the TV, we cannot perform any change on that, means that's a one way communication. On the another side, it's interactive computer graphics. It is also called active computer graphics. In this, user have control over the picture, or user can change the object. It is a two-way communication. For an example, ping pong game. In this, user can also change according to its requirement. On another scale, we can classify computer graphics in three categories. First one is generative graphics, in which we can create line, circle, ellipse, We will discuss these line, circle, and ellipse in scan conversion. Then image analysis used to generate pictures or image, and this is used for photographic images. When we have to perform some applications, some operations on photographic images, then logarithm is used. Now, about the applications of computer graphics. Computer graphics applications are not limited, but these are some examples. It is used in education as well as in training. These are only the overview we are discussing over here. We will see the applications in detail in next slide. So computer graphics is used in education as well as in training, in computer generated maps, in architecture, to present graphics, in computer arts, in entertainment, visualization, and in printing technology. So let's discuss first about the education and training. In education, one can generate the model by which we can explain the process of the event that is happening. If one want to explain the details of any process, then that can be explained very well through the model. Second, in case of training, one example of this is for the flight pilot. It cannot be that if for the training a flight pilot can take training directly on the flight, because it's really very difficult and it can be very accidental also. So what happens when training has to be provided to the airplane pilot? In that case, a simulator, flight simulator has to be created. This is like that creates the atmosphere and the controls that will look similar to the operations. And when a flight operator gets the same type of environment, then it's easy to learn the things. Using this way, saving of fuel and safety as well as airport space is not required. Means advantage to use the simulation is that we can save the fuel. There is a lot of safety, because if are providing training directly on the plane, then there are lot of passengers as well as the plane can be crashed. And in that, we want a lot of airport spaces also. Second, computer generated maps. When a town has to be designed, in that case, there are lot of planning that has to be done in advance. For an example, for the transportations, for many utilities. So to perform these in advance, one can use the computer to generate the map in the town planning. In case of architect, when architect has to design any building, then that building can be designed virtually by using the computer graphics, and it can be seen that how it will look like. Next, in presentation of graphics, the information can be presented using bar charts, pie charts, line graphs, and these information is beneficial to take the decisions in financial, in research, and many more areas. Computer art in commercial ads like advertisement, because nowadays this is the future of advertisement. So whatever the advertising we can perform, it's easy to perform the advertising using computers in the digital way. In the entertainment, in many movies, there are lot of use of the computer graphics by which there can be animations. So the motion pictures, music videos, television shows, these are the examples in which entertainment is produced in visualization. Scientific, medical, as well as business scientists use these to perform different type of visualization. The printing technology also, because everywhere on each and every product object there is printing. So how we can perform the printing better and better using printer technology, but this is not limited. These are different packages, different applications in which computer graphics operations can be performed. Right? CorelDRAW, AutoCAD, 3D Studio, Adobe, CAM, CAD, CGI, computer graphics interface, and many more. Now we will try to understand that how the presentation is going to happen on the output unit. For an example, when we are saying that how the presentation is going to happen on the output unit, means that the procedure to see the image on the output device. So we will try to understand the complete procedure for that. This is the CRT components and operations. Means CRT means cathode ray tubes. So we will discuss about the operations on the components of cathode ray tube. Cathode ray tube, the operations is performed by electron beam, and the electron beam is generated through the electron gun. These are the connectors. Those are used to give the input in the form of electricity, and this is the base. When the coil inside this is heated, coil means element is going to be heated, then the electrons are going to be produced and from the electron gun. After this, it's passed through the forcing systems. It forces the electron beam. Then there are two most important plates. By using these, the position of the object is decided. First one is horizontal deflection plate and second one is vertical deflection plate. Horizontal deflection plate moves the electron beam in horizontal direction, whereas vertical deflection plate moves the electron beam in vertical direction. Means these two plates, horizontal deflection plate as well as vertical deflection plate, decide the location of the object. The output unit or the display unit or the output screen is coated with phosphorus. So when electron beam is strike with the phosphorus coated screen, so image is going to be produced at the display. There are some basic terms. Those are related with the display device. So persistence, it means whenever a beam is going to strike, whenever a beam is going to be strike with the phosphorus, then for how much duration, that object or that pixel is going to be glow. So the duration of the glowing of the pixel after penetration of the beam. Resolutions, number of pixels, those are used to display the image. Resolutions, number of pixels, those are used to display image. Aspect ratio is the ratio of width to height. The unit of this is length or number of pixels. For an example, if we have 2 by 2 inch display unit, then aspect ratio will be 2 by 2, that is equals to 1. Or if we have an image whose width is 512 and height is also 512, then aspect ratio of that is 512 divided by 512, that is also 1. So using these we can find out the aspect ratio. Now basic things, whatever we are going to use in computer graphics, that will start from here. Till here, we were discussing about the basics of computer graphics, that how the things are going to be happen in analog. Now, when we are discussing the display device, that's digital display device, then everything is going to be in the form of pixels. A display device, suppose this is a display device, then it is made up of pixels. It is made up of pixels. This is suppose first pixel, then second pixel, then third pixel. So when we have to present an image, then the pixels corresponding to that image has to be glow, or the value of corresponding pixels will be high. Rest of the pixels will be low. So pixel is a picture element, or a smallest part that is on the video. It is also called dot. It is also called dot or picture element. Scan line is a row of pixels. When we combine a row of pixels, when we combine the pixels in a row, then it is row of pixels and called by scan line. So scan line is the combinations of pixels in a row. Raster scan and random scan we will study within a moment. So let's come on the next slide. Yeah, raster scan. Let me clear it first. So we discussed that about the scan line. So scan line is the collection of pixels in a horizontal line, or when we combine all the pixels on a horizontal line, then it is called scan line. Now, as we discussed earlier, then this is the connector. This is the electron gun from where the electrons are going to be produced. This is the electron beam. This is horizontal and vertical deflection the plate. This is control ray, and so the phosphorus coated screen. So we are not going to discuss about this. This is not our motto because we discussed this earlier. Now we will try to understand about the raster scan. I told you that scan line is a collection of pixels in a line, in a horizontal line. When from the end of a line, from the end of the scan line, the next scan line has to be glow. At that time, beam has to transfer, this electron beam has to transfer from end point to starting point of the next scan line. What happens? Suppose this is our display unit, then scan line start from top left side of the corner. This is top and this is left. So top left corner of the screen, it's start to display horizontally line by line. So it's scanned this line. Then after this, the ray has to be transferred to the next scan line, but it will also start from the left corner of the next scan line. So when the electron beam transfer from right hand side corner to left hand side corner, this is called horizontal retrace. This is called horizontal retrace. You can see from here, this is a scan line, this is next scan line. So when electron beam transfer from this position to this position, then this is a horizontal retrace line, and from the end of the scan line, means from the bottom right of the display unit, when it has to be transferred to the leftmost top corner after scanning all the scan lines, then it is called vertical retrace. So to summarize, each and everything has to be displayed using the scan line. Scan line is the collections of pixels in a row. After scanning a row, electron beam has to be transferred from the end of that row or end of that scan line to the next, in the left of next scan line. So that is called horizontal retrace. And after scanning one complete screen, electron beam has to be transferred from the last point to first point. Then it is vertical retrace. So horizontal and vertical retrace are two important things. Sometimes they ask about the difference between the horizontal retrace and vertical retrace. So in that case, we should draw the diagram of these two. Now, raster scan and random scan. There are two types of scan, random scan and raster scan. So what happens when the object has to be displayed line by line? Line by line means first first scan line has to be display completely, then second, then third, then fourth, and the pixels of the image are high, and rest of the pixels on that scan line is low. Means we draw the pixels corresponding to image only. When we are displaying a image, then on each and every scan line, we display the pixels corresponding to that object only. So picture definition is the intensity value set of the image, means whatever the image we have to display, then set of intensity of values is called picture definition. Suppose we want to display this image. Suppose we want to display this image, then what will happen? Scan line will start from the top leftmost corner, means this will be the first scan line. If any pixel of the image will come on this line, then that will be glow. If no pixel will come on this line, then all the pixels value will be 0. For an example, no pixel of image comes on this line, then this will be off. And when we are drawing the second scan line and some pixels come on this, then whatever the pixels come on this line, come on this scan line, those will be glow or those will be highlighted only, rest will not glow. So in refresh buffer, every time image has to be refreshed. So raster scan is a scan in which image is displayed scan line by scan line, means all the scan lines are going to be displayed and the coordinate of the image are going to be displayed wherever rest of the coordinate of the scan line are set to be 0 or means they will not glow. Whereas in case of random scan display, the electron beam strike only at the position where the image has to be displayed. Suppose this image has to be displayed, then electron beam will first transfer at this point, strike at this point, then it will be strike in this way continuously. Then from this point to this point to this point. In simple words, in the raster scan, the image is going to display scan line by scan line, whereas in random scan display, the electron beam strikes to the screen where the image has to be displayed. This is the difference between raster scan and random scan. When we have a black and white display system, then in that case, each and every pixel has only two values. Suppose this is a pixel and this is a black and white system. In that case, there is only two values associated with this pixel. That can be either 0 or 1. Means it represents that it is either highlight or it will not be highlight. So bitmap is the frame buffer. Bitmap is the frame buffer. We know we discussed the frame buffer in the last slide, that this is the collections of set of intensity of different pixels, set of intensity of different pixels, 1 bit per pixels, and bitmap is the frame buffer for multiple bits per pixel. There are only two values in bitmap, and in pixels there are multiple bits to store the frame buffers. So it's about the bitmap and pixmap. Generally, it is not asked in the exam. Beam penetration method. Beam penetration method is used in random scan only. In random scan only. In random scan, beam strike only at the place where image has to be drawn. It contains two layer phosphorus. One is red and one is green. Means on the display unit, phosphorus has two layers. First is red and second is green. And the color depends on the beam penetration method. Beam penetration method, that for how much speed or how much distance the beam is going to be strike with the display unit or phosphorus. So electron speed is controlled by beam acceleration voltage. Whereas in shadow mask, this was about the beam penetration. This is about the shadow mask. In shadow mask, each pixel has three phosphorus dot. You can see from here, each pixel has three phosphorus dot. One is for red, then green and blue. And the color is controlled by the electron beam intensity, like the earlier one, like the beam penetration method. There are two different type of implementations by which we can perform the shadow mask operation. This is delta method and inline method. We can perform or we can implement the shadow mask method by using these two techniques, delta and inline techniques. So in delta method, there are electron guns that has three different colors, or a electron gun has three different beams. One is for blue, one is for red, and third is for green. So when the combinations of these three beams strike with the phosphorus, and the phosphorus glass also contained three colors: blue, green, and red in a pixel, then electron beam is going to pass from the metal mask. From the metal mask. Suppose this beam is going to pass from the metal, from this piece, from this hole, from this hole. Then wherever it will strike, means the image is going to be produced by using the metal mask. It's decide that at which place electron beam has to be strike. So metal mask is used in this to draw the image. In inline method, if you will see over here, then in delta method, a mask is used, a metal mask is used that have circles, but in inline method, we have to use a mask that is slotted. Means in this, the instead of holes, these have strips. So data, so when beam has to be passed from this mask, then it decides the position of the image on the phosphorus coated screen. So the image is produced using these three beams like earlier, and the intensity is going to decide the color of this beam. So mask is used to produce the image location, and intensity of these beams are used to produce the different color. Now dot pitch. As we discussed, that screen has different colors. Phosphorus screen has different colors: blue, blue, red, and green. Blue, red, and green. So the distance between same color pixels, the distance between same color nearest pixel is called dot pitch. When we are considering these two red pixels, those are nearby, then the distance between these two is dot pitch. We can consider this red as well as this red also. So the distance between these two is dot pitch. Dot pitch of each and every pixel will be equal. If we will consider the dot pitch between these two, then it will also be equal. Now, flat panel display. Whatever we are using in our homes at this time, like LCD, VCD, those are going to reduce the size, that is volume, are more thinner, and weights are also very less. For an example, whatever we are using, TVs at our home, calculators, pocket video games, laptop computers, advertisement boards. So the volume in all these panels are going to be reduced and becoming thinner and thinner, as well as light as time passes. In plasma panel, there is a gas, neon gas, that is sandwiched between two glass plates. Bit panel, bit plane or bitmap. This is the collections of the bits. Memory block, or this is the collections of the bits that store each pixel intensity value. Collections of bits that store the intensity value of each and every pixel. Suppose this is a display screen, phosphorus coated display screen, then each pixel will have either 0 or 1 value. Means if it is highlighted, then it will be 1. If it is not highlighted, then the value of that pixel will be 0. So the collections of intensity of each pixels is called memory block. Now I think only two things are left. Yes, we will complete it today. So horizontal retrace and vertical retrace, we discussed it earlier about the horizontal and the retrace. So when the electron beam shifts from right to left to the next scan line, then this is called horizontal retrace. And when electron beam sweeps from last scan line to first scan line, it is called vertical retrace. Sometimes beam does not display each and every scan line one by one. As you can see over here, this is scan line number 1, this is 2, this is 3, this is scan line number 4, and this is scan line number 5. So in this, what is happening after scanning scan line number 1, the electron beam is scanning line number 2, and after completing the scan line 2, it's started from scan line 3, then 4, and then 5. But when a skyline is left in between. For an example, when a scan line from first scan line to third scan line, uh, in between this scan line is left, when it passes directly on the third scan line, then it is called interlace. It is called interlacing. You can see from here, it will be more clear from this diagram. This is a even field, this is a even retrace line, this is accessing only first, this is accessing first, third, fifth, and blue line is accessing only second, fourth, and sixth. So the electron beam access once even fields and at another time odd field. So when electron beam access even and old bit field or old scan line simultaneously, then it is called interlacing. Means the phosphorus coated screen is not displayed completely scan line by scan line, but in first half it is displayed all the odd fields, all the odd scan line, then in second part all the even scan lines are going to be displayed. So this is also, yes, one more thing is left. A difference between random scan line and raster scan line. In random scan line, there is high resolution. High resolution. This is a random scan where the object has to be displayed. The beam transfers at that point only. But in raster scan, object is going to be displayed scan line by scan line. So in this, the resolution is high, the resolution is low. But this is more expensive. This is less expensive. In random scan, Refresh rates depends on the resolution. Means whatever the resolution an image has, the refresh rate is based on that. Whereas it is not in the case of raster scan. As I told you that the image is displayed line by line. So in this whole the screen is scanned. Wherever in random scan only the screen that have the image has to be scanned. Means not all the screen is needed to trace. Only electron beam trace to the object pixels. Beam penetration technology comes under this, means it is used through beam penetration technology, whereas raster scan use shadow mask technology. This is not mask, this is shadow mask technology. So in this raster scan use interlacing, wherever random scan do not have interlacing method. Raster scan is used to display the realistic displays, whereas it is restricted to line drawing applications. Means it's used when we have to draw a line. So these are very important in exam. 98% they ask about the difference between random scan and raster scan. So let us summarize what we discussed today. Today we discuss about the overview of the computer graphics, that what is computer graphics. Computer graphics is the creation, operation and presentations of an object using any technology. The, this is came into existence in 1960 by William Fetters. Then these are of two types, passive and active, or it is called non-interactive as well as interactive. In non-interactive, this is one-way communication. Interactive is two-way communication. Then the applications of the computer graphics in education, computer generated maps, computer arts, entertainments, visualization. Then we discuss these applications in detail. We discuss about the different applications packages in which we can perform the computer graphics applications. Then we discuss about the control of the electron beam using the CRT cathode ray tube. Then we discuss about the basic terms, those are used, that is persistence, resolutions and aspect ratio. Later we discuss about the pixels and the scan line. Then raster scan means whatever is going to be displayed scan line by scan line. We discuss about the random scan display. Then we discuss about the beam penetration method, in which there are two methods to implement the beam penetration. First one is delta, second one is inline. After this, we discuss about the dot pitch, that is the distance between two nearby color pixels. we discuss about the retrace, horizontal retrace and vertical retrace and interlacing. Interlacing is very important. Sometimes they ask to explain about the interlacing or write down the what do you understand by the interlacing. So in that case we should try to make the diagram so that it will be more clear to understand the things. And in the last we discuss about the random and raster scan differences in detail. This is very important. They ask generally about the random and raster scan differences. So keep this thing in mind and pay more attention in the difference between random and raster scan differences. In the next class, we will discuss about the scan conversion. So